guys, welcome back to TechDose, and in this video we will be looking at product of the last k numbers problem, which is from Leetcode number 1352. Let's now look at the problem statement. In this problem, we are asked to design an algorithm that accepts a stream of integers and retrieves the product of the last k integers of the stream. We need to implement the product of numbers class in such a way that product of numbers initializes the object with an empty stream, void add integer num, appends the integer num to the stream, integer get product integer k, returns the product of the last k numbers in the current list. You can assume that always the current list has at least k numbers. The test cases are generated so that at any time the product of any contiguous sequence of numbers will fit into 32-bit integer without overflowing. Now if you look at the first example, in this case first the object is initialized and then we are making add calls 5 number of times. So the first 5 integers that you see are all add calls. Now if you try to apply the simple approach here and try to save all these items into an array, then when the add is being called for 3, then we will add 3 to the array. When the add is getting called for 0, add 0, add getting called for 2, add 2, add is getting called again for 5, add 5, and then when add is getting called for 4, append 4 to the array. Okay, so all the append operations on the array can be considered to be order of 1. So the append is getting done in order of 1, right? Now when the get product is getting called for the last 2 items, then what we can do is we can just iterate from this point for the last k number of items, and we can just take an integer result equals to 1, and we can keep on multiplying all these values. So 4 into 5 will be equals to 20. So the result will be equals to 20, right? You can keep multiplying, keep iterating from right to left. So in this particular case, the get product will be order of k time. So in the worst case, you can assume that this k will be equals to n, and therefore each of the get product will be served in order of n time, right? So you can keep on serving each of them. Like for the get product of 3, you can again start from the last point, iterate for the 3 items, and you can return 4 times 5 is 20 times 2 is 40. So you can return 40, and you can keep on solving. Whenever the add query comes, then again you can append a new item, right? So in this way, each of the add operation will take O1 time, and each of the get product operation will take order of n time. Now this is the simple approach, and let's see if this time complexity is going to work in our case. If you look at the array, the num value, then num value can be from 0 to 100, and the k value can be from 1 to 4 times of 10 to the power of 4. That means if you have 4 times of 10 to the power 4 calls for either add or get product or both combined, and let's say in the worst case I will assume that all the get product is getting a call which is 4 times of 10 to the power of 4. So in that case, you know that each of the call is served in order of n time. So these many calls will be served in order of n times of n time. That means n square. Right here I am assuming n to be the value k. Okay, so you can say k square. That will be equals to 16 times of 10 to the power of 8, which is higher than 10 to the power of 8. And that is why this simple approach will not work within 1 second. Okay. The product of the stream at any point will fit in the 32-bit integer. So since it fits in 32-bit integer, I don't need to take long integer. It will never overflow. So no need to take mod or no need to take long integer. So this simplifies the problem. Okay. So we will just be focusing on optimizing this solution, and we know that the simple approach is not going to work. So let's now look at how to optimize the solution. So if you have already solved the prefix sum problem, then you might come up with an idea of maintaining the prefix product of numbers. Now let's try to apply this idea. What do I mean by prefix product of numbers? We can take a stream simply, and in this stream, whenever the add is coming, then we will simply be appending it by multiplying by the previous value. So since 3 is the first arriving value, I will just append it as it is. When 0 is coming, then 0 will be multiplied by the previous item, and I will write 0. Now when 2 is coming, then 2 will be multiplied by the previous item, and this becomes 0. When 5 comes in, then 5 will be multiplied by the previous item, and this becomes 0. And again when 4 comes in, 4 multiplied by the previous item becomes 0. But this is not a correct order, right? We cannot just keep on multiplying when the 0 comes. There is a problem here. So in order to get rid of this problem of running zeros, like once you see a 0, after that you will always see a 0. In order to avoid this, what we can do is, whenever we see a 0, after that we will always be appending the new number. Let me show you how to do this. Let me again add all these values. So if you add these 3, then you can add 3. When a 0 comes, it just append 0 as it is, right? Whenever a number comes in, you check if the previous product was 0 or not 0. If it was 0, then append the number as it is. Don't do anything. And again, if 5 comes in, check if the previous number is 0. If it is not 0, multiply and then store. Now if the next number 4 is coming, then check if the previous number was 0, not 0, then multiply and store it. So we are storing prefix product and we are jumping over the zeros. Okay, so this is one of the ideas which can actually optimize our solution. And if you ask me how it will optimize, so let me ask you that if you are getting the get product for the last 2 numbers, then what will you do? Take the product of all the numbers here, which is 40, and divide it by this 2, which will give you the product of the last 2 numbers, which is 20, right? Okay, because it is the same concept of if you are finding the range sum in the range of L to R, then you will be getting the prefix sum at R minus the prefix sum at L minus 1, right? So it is the same technique that was in plus and minus. This one is in multiplication and division. It is the same technique as the prefix sum. So if you apply this technique, yes, you are able to serve this in order of 1 time, right? But let's try to serve all the calls. So let's try to serve this one, get product at 3. If you try to serve this one, then what is the value at the current point? It is 40. What is the value at this minus the third index? It is 0. So this is a case of division by 0, right? So if this case arises, then definitely you will get an undefined result. It is not possible. It will show you an error definitely, right? So in order to get around the division by 0 problem, what we have to do is, whenever we track that the n minus kth value is actually a 0, then we will just skip the division part and we can return the answer as it is, right? Because if you remember how we were adding the values, then while adding the values, if we encounter a 0, after that we will simply append the value as it is, and then we start multiplying from the second value, right? So you know that this 40, if this value is 40, this 40 must have come from the last 0 from wherever you had seen. After that, multiplying all the values is equals to 40, right? So if you fall into this case that the stream at n by stream at n minus k, if the stream at n minus k is 0, then that means it is a division by 0 case, and definitely you just take the value as it is and return the answer. Let's say you have tried this workaround too. Now in this case, like, we are just trying to see what works for us. So maybe this may work or this may not work. Let's see a counter example of this. Now if you apply this trick, then definitely the get product for 3 will be returning 40, which is correct. Now what happens if you ask for get product at 4? Now the get product at 4 will get the last item, which is 40, and try to divide the n minus 4th item, which is 3. And so what should this return? It will be returning 13 in an integer value, right? Which is incorrect. Because why this is incorrect? This 40 is calculated after this 0, right? And this 3 is a separate part, and this separation has been created by a 0 in between, right? So if a 0 comes in between the range, if my range from n to n minus k is actually having 0 anywhere in the position, then definitely your product will always be 0. Because if you are multiplying from n to n minus 1 to n minus 2 and so on, all the values are getting multiplied until n minus k, you know that if there is at least 1 0 in the middle, then the entire answer is going to be 0, right? So that is why this technique is not going to work. Whatever we have been discussing is not going to work for this the get product at 4. Okay. So in order to get around all these problems, like append 0 issue, we have already discussed how we will be getting around that. So that is completely okay. This is fine. But how to get around the division by 0 issue, that is a big problem. We had actually got around the problem when n minus kth value, that means the element outside of the range, if it is 0, then return the value directly. Otherwise, if 0 falls within the range, then we do not want to iterate and check it. Otherwise it will become order of k time, right, which we do not want to do. So the solution for appending 0 issue was, after 0 always append the given number directly, as we discussed. And the solution for division by 0 issue, so that you have to track if a 0 actually occurred within the range of n to n minus k. You have to track the latest position of 0. If you know the latest index of 0, then you can easily solve the problem. So let me show you all these ideas combined into a dry run. Okay, now let's say that in this case we are trying to add this particular value. So let's add with our idea. So I am always starting with 1, so that I don't have to check a new if statement. Like I have to write a new if statement. If 3 has to be appended, then I will be checking that is there a previous item or not. So if 3 is the first item, then it will just be appended as it is. So just to simplify the if else statement, I will just be appending a 1 in the beginning. It is pre-filled, right? It is not going to change our answer anyway. Now I will be starting with n equals to 1. This is index 0, and this is where your n is pointing. Now I will be tracking the last 0 index as well, which is -1. That means there is no 0 that I have seen. If a 3 comes in, then 3 gets appended. Okay, 3 gets appended. Now 3 will get appended only by multiplying by the previous value. Okay, so how to append it? Whenever you get it stream, whenever you append a new value, so stream dot append whatever you get from the back of the stream, that means stream dot back, and multiply it by the current value, which is the num value. Okay, so what is stream dot back? It is 1. What is the current value? 3. Multiply 3 with 1, and here you have a 3. Okay, now let's go and add 0. Now you know that whenever a 0 comes in, you just have to append it, right? Definitely whenever you appended, your n value will increase. We do n plus plus. When 0 came in, 0 will be multiplied with 3, it became 0. Okay, and now since a 0 was seen at index number 2, so I will be updating the last 0 index to index number 2, right? And my n will become n equals to 3, which is the third index. Again, see these two. Look at the previous index. The previous index is 0, so just append the value as it is, that is 2, and increment the value of n. This n is reaching to index 4. Now again you look at the value 5. Look at the previous index. It is a non-zero value, so just multiply and save it. So this is 10, and update the index of n, right? Now in this case we are asked about getting the product for the last two numbers. So what is my value of n? It is equals to 5. And if I want to get the product of the last two numbers, then I have to get from n minus 1 till the n minus k minus 1. N minus k, you can say, right? So n is 5, n minus k value is 2, n minus k is 3. So I want the product from n minus 1 to n minus k. So how you can derive that is, you take the stream value at n minus 1 and divide it by stream value at n minus k minus 1. That means divide it by just the previous value, this one, so that you can get the product in the middle. But if you look at it, the stream at n minus k minus 1 is 0, and this was the special case that we were talking about, right? If this is 0, then whatever is 10, that will be the result, isn't it? So if you look at the code, I have already written this case is the one where stream at n minus k minus 1, if it happens to be 0, then return the stream at n minus 1. That means whatever is the value must have been the product of the range that we are talking about, right? Now this case is saying if a 0 lies within the range in which we are interested. So we will already be checking that. So last 0 index, is it greater than equals to n minus k? N value is 5, n minus k value is 3. The last 0 index is at 2. So 2 greater than equals to 3 is incorrect. So this will not run for our case of get product 2, right? But this second condition will run. If the second condition is also not running, then this is the general case. This will definitely be, it is just the division, like the prefix product technique, right? Now we will be going to the next one, get product 4. Now if you are trying to get the product of the past 4 items, what is the value of n? It is 5. What is the value of n minus k? It will be 1. N minus k is 1. Now what is n minus k minus 1? It will be equals to this index 0. Now you check the first condition. If you want the product in this particular range, then do you have a 0 in between? So check the last 0 index. So last 0 index is 2 and it is greater than equals to your n minus k. So that is why a 0 lies within the range in which we want the product, and so simply return a 0 for this. So 0 will be the answer for this one. Okay, so I think it is getting clear with you. Now let's append a 0. If you append a 0, simply append a 0, because if you multiply with the previous item, it will be 0 only. If you want to append a 3, check the previous item, the back item, and if the back item is 0, then simply append the number as it is. The n value will keep on updating and the n value will now be pointing to 7. Okay, now we are asked about get product of the last item, that means one item. So the n value is equals to 7. The n minus 1 value, that means n minus k value, equals to 6. So if you look at the last 0 index, like we have seen 0 at index number 5, so the last 0 index must be updated to 5. Is this 5 greater than equals to 6? No, and that is why there is no 0 within the range in which I am interested to find the product. Now the second thing, is the previous item of my last range, that means n minus k minus 1, is it 0? So yes, it is 0. So whatever value I am seeing at n minus 1, that must be the answer, and that is why 3 will be returned in the answer. Now let's append this 2. So if you append 2, just look at the previous item, it is non-zero, so multiply and store it. If you append 4, just look at the previous item, multiply and store it. If it was 0, then I will not multiply, right? So it will be 24 now. Now if you are solving the get product of 2, then your n value is at 9. Your n value is at 9. Okay. Now find out the n minus k value. K value is 2 here. So n minus k value will be 7. Look at the last 0 index 5. So is 5 greater than equals to 7? No, it is not the case. So that means there is no 0 within the range in which I am trying to find the product. So the product definitely will not become 0. Now look at the special case of if at n minus k minus 1, is there a 0? So there is no 0. That means I have to go with the usual technique of taking this and dividing by n minus k minus 1, right? So take this 24 and divide it by 3, the answer will be 8, and that is how 8 will come as a result. So this is the entire dry run, and in this entire dry run, you know that for adding, there are only two cases. If the previous item is 0, you just append the num value as it is. If the previous item is non-zero, then you multiply the previous value with the current value and store it. This is how we add. Both of these techniques are order of 1 for each of the add query. Now if you try to find the product, there are three cases as mentioned here. The first case is, have we seen a 0 in the range in which we have to find the product? So if n is pointing here, I am interested from n minus 1 to n minus k. So if there is a 0 lying somewhere in between, then definitely the product will be 0, and that is why we are returning 0 here. But if 0 is not lying anywhere in between, and if the product here is showing as x, then if just the immediate previous value was 0, then that means from the right point of this till n minus 1, my value must be x, and that is why I will be returning the stream at n minus 1 with that case, right? Whatever is the product at n minus 1. Otherwise, if the previous item of my range is not 0, then in that case I will just be if it was y, then I will be taking x here and I will be dividing it by y to get the product in this range. Okay, and that is what will be returned. This is the general case of division. Checking all these are order of 1, so get product is also order of 1. So each of the query add and get product are both order of 1, and since we are doing it n times, the total time complexity is order of n. Since we can have maximum n number of items in insertion, therefore the space complexity can go to order of n. I hope this was clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, I have taken a stream and I have initialized it with just a single value 1 to as a pre-filled value to get started. N will be always pointing to the the next index where there is a vacant space. The last 0 index is used for tracking the position of 0. Now here is the constructor initializing the object, and when the object is initialized, I will make n equals to 1, because at 0th position I have already filled a 1. So I said that n will always be pointing to the vacant space. So that is how n is pointing to 1 here. The last 0 index is actually pointing to the 0 position that we have seen. We haven't seen any zeros, so that's why I have made it point to -1. Okay, so this is the constructor initializer. After this, if we have the add function, now in the add function you will just be checking if the current number is 0. If the current number is 0, then your last 0 index will be updated to the new index, which is n, because n is the position where the 0 will get inserted, right? And if the previous item was 0, no matter what item you are inserting, if the previous item was 0, we will not be multiplying the num, we will just be inserting the num as it is. Otherwise, if the previous item is not 0, then I will be multiplying with that value and inserting it. Okay, and whatever I do, I will definitely be going to the next index, because definitely I am inserting something in the add function. Now once this is done, we will see the get product function. In this case, we are asked to find the product from n-1 to n-k. So we want to get the product in this range. So first of all, I will be checking if the last 0 index is lying somewhere in n-k to n-1. If it is lying, then we will simply return a 0, because making a product will always result in 0 value. Otherwise, if just the previous value of n-k is a 0 value, then in that case, whatever is the product at the end, that one will be returned. And if the previous item is not a 0 value, if this was y and here you have an x, then you will return x by y, which is stream at n-1 by stream at n-k-1. Okay. So this is the entire approach, and I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.